This is Mrs. Haslauer's video on Similar Figures Continued. Guys, we're basically done with the unit. We're wrapping it up. So between today, tomorrow, and then a little bit of review, you're going to take your test. So make sure that if you're confused still, that you're coming in and seeing me and asking me questions. It's much easier to work one-on-one. So here we go. We got our note sheet. We're not really learning anything new today. We're just taking what we already know and applying it into a little bit of a new way. So all they give us with this picture is that AE is parallel to CD. So all it's really telling us is that this line is parallel to this line. Again, parallel is denoted by the arrows. All right, so you can leave them like they were before. You can close them in, all right, however you want to do it. But it's very important to know which two lines are parallel. So again, AE is parallel to CD. They want to first have us show that triangle AEB, so the top triangle, is similar to triangle DCB. How are we going to do that? Well, we have to show that corresponding angles are congruent. And the other piece is to show that the side lengths are in proportion. Right? But all we really need to do to prove something is similar is that two corresponding angles are congruent to each other. So you might say to yourself, well, how are we going to do that when they don't give us anything? Well, the parallel lines are the really important part here. Hopefully, looking back, you remember the whole unit we did with parallel line and transversals. If a set of parallel lines are cut by transversals, then you know that the alternate interior angles are equal. Remember, alternate means opposite side of the transversal, and interior means inside the parallel lines. So because of that, I can say that angle A will be congruent to angle D. Same thing is true for angle E being congruent to angle C. Angle E is congruent to angle C. The reason for both of these is that alternate interior angles are congruent. Congruent means the same. So there's 2 out of the 3. How are we going to prove that this angle here has to be exactly the same as this angle here? Well, remember, when you have 2 lines that intersect, the angles across from each other will be congruent because they are vertical. Now, this is not just angle B. We can't say angle B equal to angle B, so you got to use your letters. Angle A, B, E, just follow the order, A to B to E, is congruent to angle DBC because they're vertical angles. Now we've got our corresponding angles are congruent to each other, so we know for a fact that the 2 triangles have to be similar as long as their side lengths are in proportion, and that's where we're headed to right now. We want to find the length of BE, B to E, right here. Now some of us are still having a hard time setting up our proportions. If you have a hard time deciding which sides are corresponding to each other, please redraw your picture. They're upside down to one another. It's very, very easy to redraw the picture. It doesn't have to be perfect. 9 and 15, and then I'm just going to flip the bigger triangle over. Now I'm going to make it as similar to this triangle as I can, meaning I want angle 2, I want the 1, and then I want the 3 here. So here we go. The side length between the 1 and the 3 is where the 40 was. 1 and 3 is 40. And then X is between 2 and 3. 2 and 3 is X right here. So there's my triangles all set up with the corresponding sides. All you got to do is set up your proportion. 9 is to X as 15 is to 40. We've gotten a lot better with our cross multiplying over this week. And we get 15X is equal to 9 times 40, which gives us 15X is equal to 360. They're connected by multiplication, so you're going to break them by division, and you get X is equal to 24. And you're all set. And then the last question is find the scale factor. You really only need 1 pair of corresponding sides to find your scale factor, because if the triangles are similar, the scale factor will be the same for all of them. So you can pick whichever one you want, or you can plug in for both. Right now we know that 9/24 needs to be the same thing as 15 over 40. Well, we can reduce both of these. 9 and 24 can be reduced down by 3. And 15/40 can be reduced by 5. When you reduce these fractions down, what you end up with is 3/8 is equal to 3/8. So the scale factor is 3/8. Now, the last thing to talk about is word problems. Now, please do not convince yourself that this is anything too hard. Whenever we have done word problems in the past, I've always recommend that you draw a picture. I'm going to do the same thing here. Please draw a picture. It can be as detailed or as basic as you need to get the problem right. In this case, it says a giraffe is 18 feet tall and casts a shadow of 12 feet. Corey casts a shadow of 9 feet. How tall is Corey? It's as simple as understanding that you're comparing two things, height to shadow, as height is to shadow. I'm going to draw myself a little picture. So here's my giraffe that's 18 feet tall. You can draw a little giraffe if you want to. And shadow is always going to be the length along the ground. So it's got a shadow length of 12, which makes a triangle. And then I've got Corey, who casts a shadow that's only 4 feet. Well, we don't know how tall Corey is, so we make that a variable. Forming our two similar triangles, you're going to set up your proportion. 18 is to 12, as x is to 4. Whenever you have two fractions set equal, you're going to cross multiply, and you get 12x equals 4 times 18. 12x equals 72. Divide by 12. And you get x equals 6. It's not just x, but that's Corey's height is going to be 6 because they're in proportion to each other. Do one more for practice. When a Ferris wheel casts a 20-meter shadow, a man 1.8 meters tall casts a 2.4 meter shadow. How tall is the Ferris wheel? With all the decimals and the unnecessary information, it sounds really complicated. But if you break it down and draw a picture, hopefully it simplifies it down for you. We've got a Ferris wheel that's casts a 20-meter shadow. So we don't know how tall the Ferris wheel is, but we know it casts a 20-meter shadow. So it's up to you. If you want to draw some sort of Ferris wheel here to keep track of what you're talking about, then please do it. I'm very bad at drawing, so I'm not going to, but it's up to you. And then they're comparing that at the same time to a man that's 1.8 meters tall and only casts a 2.4 meter shadow. So he's significantly smaller, but it's still a similar triangle. We want to find out how tall the Ferris wheel is. So I know we're missing a side length. We're missing the third side, or what looks like a hypotenuse here. But that's okay. You only need two sides to make your proportion. So x is to 118 as 20 is to 2.4. They have to be in proportion. Now we're going to cross multiply like always, and we get 2.4x is equal to 1.8 times 20. 2.4x. Now, please do not reach for a calculator. We need to practice. This is good review on how to multiply by our decimals. Many of us are still nervous when we see things like that. So a little bit of practice is definitely a good idea. You just line them up. You don't have to worry about lining up your decimals or anything like that. That's only when you're adding and subtracting. You're going to start by multiplying the 8 through. So 8 times 0 is 0. 8 times 2 is easy enough. 8 times 2 is 16. Your placeholder, 1 times 0 is 0, and then 1 times 2 is 2. You add up your numbers. 0, 6, 3. Now here's the trick. Because there's one number behind the decimal, you got to move the decimal once, and you get just plain old 36, not 360. Now the 2.4 is connected to the x by multiplication, so you're going to use division. Again, we're going to practice here. Please do not reach for a calculator. The 36 is in the numerator. The 36 goes inside the nice house. It's kind of a little trick on how to remember. And 2.4 goes on the outside. You cannot divide with the denominator with the decimal in there. You have to move the decimal once, so it's behind the 4. But if you move the decimal once on the outside, you got to move the decimal once on the inside. What do we fill in? We call it, the bunny hole when we were talking about scientific notation and things like that. You fill it in with a 0. So what you're really dividing is 24 into 360. 24 goes into 36 once, with a remainder of 12. Drop your 0. 24 into 120 is 5, because 24 times 5 is 120, with a remainder of 0. So even though it looked challenging with your decimals, and I know a lot of you would have been very nervous doing that on your own, you do get the whole answer of 15. Now, please do not just write down the 15 and think that you're done. I want you to check to make sure that it makes sense. In our original problem, we didn't know the height of the Ferris wheel, but we did know that the shadow was 20. On the smaller triangle, we knew that a height of 118 was producing a shadow of 2.4. If the shadow was longer than the height of the man, when you have your other triangle, you still need the shadow being longer than the height of, this case, the Ferris wheel. We need to get in the habit of making sure that our answer makes sense. That's all we're going to do tomorrow. We're going to keep practicing with our similar figures. Please make sure you take a second look at this problem. This required your knowledge of parallel lines and transversals. If you have any questions, please let me know.